Welcome back to TECHMargadarshi. In this Part 5 series, we'll move deeper into Java by learning arrays, strings, constructors, and important keywords like this. These concepts are essential for writing structured, efficient, and real world Java programs. So let's get started. Now, here is the first topic: arrays in Java. Now, let's understand one of the most important data structures in Java: arrays. An array is used to store multiple values of the same data type in a single variable, instead of creating separate variables for each value. All elements in an array are stored in contiguous memory locations, which makes access faster and more efficient. Arrays in Java have a fixed size, meaning once an array is created, its size cannot be changed. Each element is accessed using an index, and indexing always starts from 0. Java arrays can store both primitive data types like integers and object types like strings. Using arrays helps improve memory management, reduces code repetition, and makes programs more organized. In the next slides, we'll also look at the different types of arrays supported by Java, along with examples. Now let's understand the different types of arrays available in Java. First, we have the single dimensional array. This is the most commonly used array type and stores elements in a single row. Each element is accessed using one index, starting from 0. It's perfect for storing list like data such as marks or scores. Next is the multi-dimensional array. This is an array of arrays and is usually represented in a matrix form with rows and columns. It uses two or more indices and is commonly used for tables, grids, or mathematical matrices. Then we have the jagged array. In a jagged array, each row can have a different number of elements. This makes it memory efficient and useful when data sizes vary for each row. Finally, Java provides the length property to find the size of an array. It tells us how many elements an array can hold and is not a method, but a built in property. Understanding these array types helps you choose the right structure for your data and write efficient Java programs. Now let's understand strings in Java, which are one of the most commonly used concepts in real world applications. In Java, a string represents a sequence of characters, and it is immutable, meaning once a string object is created, its value cannot be changed. Whenever you try to modify a string, Java actually creates a new object in memory. This makes strings safe and secure, especially in multi threaded environments, but not ideal for frequent modifications. To handle situations where we need to modify text frequently, Java provides StringBuffer and StringBuilder. StringBuffer is mutable, meaning its value can be changed, and it is thread safe because it is synchronized. This makes it suitable for multi threaded applications, although it is slightly slower. On the other hand, StringBuilder is also mutable but not thread safe. Because it is not synchronized, it offers the best performance and is commonly used in single threaded applications where speed is important. So, to summarize, use string for fixed text, string buffer for thread safe modifications, and string builder when performance matters. Now, here's the next topic: ways of creating string in Java. In Java, strings can be created in two different ways, and understanding this is very important for interviews and memory management. The first way is using a string literal. When we create a string using double quotes, Java stores it in the string constant pool. If another string with the same value already exists, Java reuses the same object, which helps save memory. That's why two string literals with the same value usually point to the same memory location. The second way is creating a string object using the new keyword. In this case, Java always creates a new object in heap memory, even if the value is the same. So each time you use new string, a different object is created with a separate memory reference. Both approaches create immutable strings, but string literals are more memory efficient, while new string gives you a fresh object every time. Now let's understand an important concept in object oriented programming: constructors. A constructor is a special method that is automatically called when an object of a class is created. Its main purpose is to initialize the object, meaning it assigns initial values to instance variables. In Java, a constructor always has the same name as the class, and it does not have any return type, not even void. Constructors help ensure that an object starts its life in a valid and meaningful state. Constructors can be parameterized, where we pass values while creating the object, or non parameterized, where no values are passed. If we don't write any constructor explicitly, Java automatically provides a default constructor. In this example, the constructor initializes the id and name variables when the student object is created, making the object ready to use immediately. Now, here is the next topic: types of constructors in Java. In Java, constructors are mainly classified into two types: default constructors and parameterized constructors. Let's start with the default constructor. A default constructor does not take any parameters. If you don't create any constructor in your class, Java automatically provides a default one. Its main purpose is to initialize objects with default values and perform basic setup tasks when an object is created. Next is the parameterized constructor. As the name suggests, it accepts parameters. This allows us to pass values at the time of object creation. Parameterized constructors help initialize instance variables with custom values, making our code more flexible and reusable. Both types of constructors are called automatically when an object is created using the new keyword, and they play a very important role in object initialization. Now, here is the last topic of this series: this keyword in Java. Let's understand this keyword in Java, which is a very important concept in object oriented programming. In Java, this refers to the current object of the class. It is mainly used when instance variables and constructor parameters have the same name. In this example, you can see that the constructor takes parameters called ID and name. To clearly tell Java that we are assigning values to the instance variables, we use this .id and this .name. This keyword helps avoid confusion, improves code readability, and ensures the correct variables are accessed. It can also be used to call current class methods or even another constructor within the same class. Understanding this is essential when working with constructors and object initialization, especially in real world Java applications. And that brings us to the end of part 5 of our Java learning series. Today, we explored some very important core concepts like arrays, different types of arrays, strings, constructors, and the this keyword. These topics are fundamental to object oriented programming and are widely used in real world Java applications and interviews. Make sure you practice these concepts with small programs, because hands on coding is the key to mastering Java. In the next part, we'll move forward into more advanced and exciting topics. So stay connected. Keep learning, keep practicing, and I'll see you in the next session. Thanks for watching, and happy learning with TECHMargadarshi.